All right, hi everyone. I am going to be in a conference while you're reviewing for your Trig test. So I figured what I could do is I could show you a few of the examples. So please don't watch this video if you're trying things on your own. If you only have a specific question that you want to look at, go ahead and scrub through the video until you find the question number that you're looking for. But otherwise, I'm just going to go in order to describe each of these questions. So for question number 1, it is asking you to find the angle of elevation formed by this ramp. So we are going to have to be finding this angle right here between the 11.75 and a side that's not given to us. So what we are going to end up doing for this is have the sine of this unknown angle, I'll call x, equal 4.5 over 11.75. So what I need to do is take the inverse sine of both of these sides, and that will end up giving me the value of x. So this will have to give you use of the calculator, and then you're going to have 22.5183, or approximately 23 degrees if we round that. All right, the next problem, number 2, we are now on to. Which expression is always equivalent to the sine of x when x is between 0 and 90? Well, we said that there was a special relationship between sine and cosine. The sine of an angle is equal to the cosine of the complementary angle. So something like the sine of 10 is equal to the cosine of 80. Or we also have that the sine of 25, that would end up equaling the cosine of 65. So you can always take your sine number and you can always subtract it from 90 to get this one. So if you have sine of x, the cosine of 90 minus x would represent the complement. So that one will end up being choice 1. All right, now we're on question 3. It wants to know what the value of the tangent of b is. So the tangent of b, well, tangent is opposite over adjacent for our ratios. The opposite of angle B ends up being 8. The adjacent side is the non-hypotenuse side that forms that angle, so that's 15. So the tangent of B is equal to 8/15. This is not asking you to find what the number of degrees of angle B is, it's just asking you what is the tangent of B. So it's asking us to round the decimal form of 8/15. And 8/15 is 0.53 with the 3 repeating. It is choice 2. Okay, we are now looking at question number 4. It's asking for this diagram to say for the nearest foot, determine and state the length of the ladder. So the length of the ladder is what is leaning against the house. So I will go ahead and I'll mark that X. The 30-foot mark on this side of the diagram is corresponding to also how high up the building that ladder is reaching. So for this question, we would know that the sine of 70 is equal to 30 over X. What we can do is cross multiply or use the shortcut that comes from cross multiply and switch the location of the sine of 70 and the x. And so we follow rounding instructions. This says to the nearest foot. When I type this in, I can take the decimal that I obtain and note that this is approximately 32 feet. So that's our first page done. Let's go ahead and take a look at the next one. So here's number 5. Kathy wants to determine the height of the flagpole, shown in the diagram below. She uses a survey instrument to measure the angle of elevation to the top of the flagpole, and it's 34.9, so we can see we are given that angle. She then walks 8 meters closer, and then we have a new angle. Because we got closer, we have to look with more of a steep angle up to the top of the flagpole. Okay? That instrument that she's using, though, is 1.7 meters high. We are going to have to take that into account. It wants us to find the height of the flagpole. So I have to find the height of the flagpole. Unfortunately, that is only within a right triangle that is, oops, sorry, wrong thing. Let me fix that. That is only within a right triangle where we don't have enough information to find that height yet. That right triangle only has 52.8 degrees and none of the side lengths, so we don't have enough information there yet. What I would suggest is we can go ahead and look at this non-right triangle instead here. We are going to be able to know how to figure out not directly the height of the flagpole, but one of the pieces of information that will eventually help us find it. I can find the length of the distance from the second measurement to the top of the flagpole. That is going to be able to then help me find the height of the flagpole, I'll call it y, afterwards. So for this triangle, which is non-right, we would either have to use the law of sines or the law of cosines. In this case, we would use the law of sines because the sine of 34.9 is across from x, and we have the 8 degrees that we can use, sorry, not 8 degrees, 8 meters that we can use, okay? But what we end up having here is a sine of an angle that we don't apparently know right away, but we actually do. Because we have the 52.8 degrees, we know its supplementary angle here. So if we do 180 minus 52.8, we get that this is 127.2 degrees. And now this triangle that I've highlighted in green has two of its angles, so we can do those two, take away from 180 degrees, and know that the angle up here is 17.9 degrees. And so that 8 meters that was marked on the bottom, that's across from the 17.9. And that's how the law of sines can help us find this value of x. So if I go through that, I would know that x times the sine of 17.9 is equal to 8 times the sine of 34.9. And I'd be able to divide sine of 17.9 on both sides. Because I'm going to have to use this to find something else in the future, while I am only writing down on the screen right now 4 decimal places that this calculation ends up equaling, I am going to store that on my calculator for future use. And now I'll be able to transition back to this right triangle, use x to find y. Because from the 52.8 degree angle, we have an opposite side and we have a hypotenuse, so we can use the sine of 52.8 to help me go ahead and say that's equal to, wrong one, y over x. Well, our x is stored in our calculator, so that is going to be y over that 14.8920 number, and I will be able to now multiply that to the other side and say the sine of 52.8 times that stored value is going to end up being the value I'm looking for. Sorry, it's not erasing. There we go. And so y in this case is approximately 13.5620. So now we are able to find the height of the flagpole. The height of the flagpole is that value y plus that extra 1.7 meter height that the instrument we were using has. So that y value plus 1.7 would end up being 13.6 approximately if we round for those instructions, plus the extra 1.7. And so if we add those together, we will end up getting 15.3 meters tall altogether. That one you might want to relook at if you watch me go through it, because it is a two-parter. Okay. Number 6. The angle of elevation from a point 25 feet from the base of a tree on level ground ends up being 30 degrees. Okay, that is 25 feet along the ground. That will help me find the height of the tree. However, you'll notice there's no rounding instructions because this is one of our special right triangles. So what we are able to do in this case is use the x radical 3, 2x ratio. We can see a side across from 30 is x. It's matching perfectly with my ratio. We have a right angle where the tree is growing. So a 60-degree angle is across from 25. So we now know x radical 3 is equal to 25. So if I divide both sides by radical 3, I get something that I am going to have to rationalize. So if I multiply that top and bottom by radical 3, I get 25 radical 3 over 3 feet. And that would be my exact answer. Okay. We're going to pause there. I'm going to get out my key for the rest of them for a second. Okay. So now we can move on to number 7. So in this diagram, we have 75 degrees. Okay, once again, we have another ladder here. So we are just going to have to go ahead and figure out what's going on. We want the length of the ladder again. So I will go ahead and I'll mark that x. So we now know that the sine of 75 degrees is equal to 15 over x. So we can have the x and the sine of 75 switch places. So x equals 15 divided by the sine of 75. And so if we approximate that, it is about 15.5291, or to the nearest tenth, 15.5 feet. Okay, we are done with 7. We are going to now move on to question number 8. We have another question that has the potential to be a two-parter here. So it says, as modeled below, a movie is projected onto a large outdoor screen. The bottom of the 60-foot tall screen is 12 feet off the ground. The projector sits on the ground at a horizontal distance of 75 feet from the screen. We want to know the measure of the projection angle, because the projector is not perfectly projecting along the ground. It is creating this angle here. So if we want to do that, it might be helpful to also know the value of the other angle that is not part of the projection. So I'm going to mark that x. And the reason I'm going to do that is we have two right triangles here. We have this overall right triangle with the ground and the top of the projection, but we have another right triangle with the ground and the bottom part of the projection. And so if I can use those two right triangles to figure out two angles, I'll be able to subtract the angle measurements from one another and find what they're asking for. So I have that the tangent of x would be its opposite side, 12, compared to its adjacent side, 75. So I can go ahead and do the inverse tangent of that fraction and know that x is approximately 9.0903, which I will store on my calculator. Additionally, because of the overall large triangle I highlighted in green, I also know that the tangent of x and the angle they asked us to find has to be its opposite side, which totals to 72, compared to the same adjacent side, 75, that we looked at a few moments ago. And so the two angles put together will have an inverse tangent equal to that amount. And so x plus the angle I've been asked to find is around 43.8309. And so now I have the ability to take the two stored values on my calculator and subtract them from one another. So please keep in mind, you have to remember which ones you've stored where. Okay, but if I do this subtraction, I end up getting 34.7406 with the 4 decimal places, rounded to the nearest tenth, that is 34.7 degrees. So this is another two-parter. I think this one's not as bad as the last one because it's two direct trig relationships instead of the law of sines or cosines having the potential to be needed to use. Okay, so we have our special right triangle questions here. What we can see for question number 9 is we have a 45, 45, 90 triangle. So that is in the ratio of x to x to x radical 2. So in this case, both a and b are our x values. That means x radical 2 is equal to 16. So I can solve for both a and b at the same time by doing that division. I have to rationalize this though. So I multiply the top and the bottom by a square root of 2. 16 radical 2 over 2 is my value, but that for a and b can be reduced, means a and b are both 8 radical 2 units long. And then for our 30, 60, 90, we can see across from the 30 I have y, so I'll keep that y. Across from the 60, I'll maybe use my ratio and call that y radical 3, and that means this is 2y. So this one's actually simpler than the last one because we don't have an irrational number to deal with. We can see 2y, that is equal to 14. So we know y is equal to 7 in this case. And then because I said x was equal to y radical 3 from the ratio, in this case, x is 7 radical 3. And so we can do these questions with missing sides without the perfect use of trig, and instead the special right triangle so we don't have to round. All right, we're done with question number 9. Oh, did I not have a question number 10? Oh, that was 9 and 10. Okay. Here's question number 11. All right. So what is the area of a regular hexagon, which is inscribed in a circle with a diameter of 16? So that circle has a radius of 8 then. So if I want to go ahead and use trig to my advantage here, I can use the trig to find the apothem length. Okay, but unfortunately, that 8, could be used in another way. But I want to show it with trig since we have a trig test. So I will go ahead and I'll put the 4 here, since that is across from the 30-degree angle, and the apothem bisects the side, which has the same length as the radius. But let's use the ratios to discuss what a is instead of using something else like Pythagorean theorem. What we can do for this is we can use x to x radical 3 to 2x as our relationship. So the side across from 30 will be 4. That means the side across from 60 will have to be 4 radical 3 in order for 2 times 4 to become the 8 that we also have here. So we now know that the apothem is 4 radical 3. So I can use 1/2 NBA to go ahead and figure out the area of this shape. So the area is 1/2 times the 6 sides of the hexagon times the 8, which is the full base length of the hexagon, times a 4 radical 3. And remember, you can type that on your calculator by leaving off the radical 3 and multiplying it back at the end. 96 radical 3 square inches would be our answer. Okay. We're going to now look at question number 12a and 12b. Okay, we can see we have non-right triangles here, which means we have 2 different scenarios. All right, in the question 12a, we can see we only have 1 angle given to us. And since the law of sines needs the sine of 2 angles, and therefore maybe 2 sides to find it, that's probably not ideal for this situation. So instead, when I have 1 angle, 2 sides, and 1 side that's missing, that's better for law of cosines. So I can say that a squared will equal b squared plus c squared minus 2bc times the cosine of a to figure out this. So the side that I'm trying to figure out is our x, so I will let that be x squared. But we do know the other 2 sides are 53 and 46, so I can plug those in. And I can subtract 2 times 53 times 46 times the cosine of the angle across from what we're trying to solve, the 87. So I get that x squared is equal to 2,809 plus 2,116 minus 4,876 times the cosine of 87. That is something you'd be expected to type in all at once to see that x squared can approximately be 4,669.8099. I wrote the 4 decimal places, I store it in my calculator, or I use the answer key on my calculator because I need to take the square root of that exact number. And so this approximately ends up becoming 68.3360, or 68.34 to the nearest 100th this time around. The one on the right, 12b, that's going to be a law of sines question, because as I mentioned before, law of sines involves 2 angles. So we can say the sine of A over little a is equal to the sine of B over little b. So I'm going to have to use a sine of 102, but I don't use a sine of 35 because the blank angle is what's pointing to x. So I have to do 180, take away these other angles to figure out that 43 degrees is my remaining angle. So I will use the sine of 43. So the sine of 102 pairs with 53. The sine of 43 is what pairs with x. And so now I can keep solving this. If I cross multiply, I would be able to get that sine of 102 times x equals 53 times the sine of 43. Sorry that I'm squeezing that in there. And then I divide both sides by the sine of 102. So that gives me x is equal to 53 sine 43, all divided by sine of 102. And if we type that in our calculator, we get an approximate value of 36.9534, or rounded 36.95 as the missing length. Oops, I said 5 and I wrote 3. 36.95. Okay, so I know I went through quickly with the review questions, but that was so that you can scrub through and look at them at any point. Okay, we also have the law of cosines homework that was up that you were supposed to look at. And as I mentioned, I will still be in school for extra help. I just had that meeting that got called during your class. Okay, I will talk to all of you soon.